Alright, let's take a look at one of the problems from your linear regression handout 13. This is problem 2 in the handout, and for this particular problem I'm asking you to do a few steps in determining the values of our unknowns. So I've given you some data here on the fluid flow and the height that was collected using this nonlinear uh, um, equation. And I've gone ahead and I've entered in the data into our calculator. So the first step asks you to go ahead and enter the original data into our calculator. The next thing I wanted to do is determine the appropriate linear transformation for this equation. And so for that, I'm going to use the natural log. And so I'm going to use this at a steady state. So if I take the natural log of both sides of this equation, I'll get Ln of f is equal to Ln of k plus p times Ln of h. Alright, so this is our linear equation for this non-linear formula that we use to collect this particular data. Alright, and so now I have a linear equation, and I want to now enter in this data onto the other side of my graph here. I want to get the natural log of f here, and I want to get the natural log of h here. Alright, and so those are the two that I need to do. So in one of these I will take the Ln of h, alright, and on the other one I'll take the Ln of f. Alright, and I'm going to do this for each one of my data points that I have in this table. Alright, and so I'm going to do that in our calculator over here for L3. Alright, and so to do that, all I'm going to do is go up over to L3. I'm going to go to the top of the calculator here, and like I showed you guys in previous videos, if I want to take the natural log of all of these values, I can simply do that to L3. Alright, and so L3 is going to equal the natural log, alright, of L1, which is my second key, and then L1, number 1 here. Alright, I do that and hit enter. Alright, and I can see that it went ahead and took the natural log of all of these values here. Alright, so that's the natural log of h that would go into this column here. So you could just enter that in and or copy it. Okay, and then I'm going to go over here to L4 because I need to do the natural log of my fluid flow as well of f. Alright, and so L4 is going to equal the natural log of L2, which is second, and then number 2 here. And so now I hit enter. Alright, and so now I have all the values for the natural log of f. So what I'm looking at here, L3, L4 would be exactly what I would see in this column, Ln of h, and this column, Ln of f. Okay, so now I want to get my linear regression equation. Okay, so I come over here to my stat menu. Alright, so stat, I'm going to go over to calculate, and I'm going to calculate number 4, the linear regression. So number 4. And instead of my x list being L1 this time, my x list is actually going to be L3, which is h. And remember, Ln of h needs to be the x, alright, because this is, alright, y, right, equals mx and b here. So Ln of h needs to be my x list, alright. Ln of f needs to be my y list, alright. So my X list is actually L3. So second and the number 3, change that to L3. And my Y list needs to be L4. Alright, so second and the number 4, L4. Alright, I can store this in my Y equation again. So I'm going to store this regression equation in my Y. I come down to variables, over to the Y variables, the function, enter, and I'm going to save this in the Y1 function. I can then scroll down to the calculate and calculate my equation. So I press enter. Alright, and so for this, my y equals ax plus b equation. Alright, so this means that I have, alright, the actual equation, that my linear regression equation is this y equals 0.996x, which is what we see up here, alright, plus 0.9346, which is my b. So here's my y equals mx plus b, my linear equation here. And you can see I get also an r squared value of 0.934. Alright, and I just did this in Excel so that we could show you as well the plot and the linear equation, but also corresponds directly to what we see in our graphing calculator as well. And so this confirms, if we were to go and graph this like we did in the last video, show you exactly what we have here with the particular graph. However, the cool part about this is that we can take this with our linear equation up here that we created, and we can solve for our unknowns. So we've reported the regression equation and the r squared value, and so we want to identify, find what those values of our unknowns are. Alright, and we know that P, alright, is simply the slope of our regression equation, right? P is here, right? And so P is simply our slope, or M, in this equation. So we can come over here and look at our equation. Here's M, alright, here's our slope, so P is equal to 0.996. Alright. The next unknown I need is this K value. Alright. Well, K is equal to, or actually the natural log of K, alright, ln of K is equal to my y-intercept, B. Okay. And so ln of K is equal to B. Alright. And in this case, ln of K is equal to, I can come over here, look at my y-intercept, is equal to a positive 0.9346. Alright? But I want K, I don't want the natural log of K, so I multiply by the exponential on both sides. K is equal to the exponential of 0.9346, which is equal to, alright, approximately 2.95. I'm sure I'm rounding a little bit there on that one, but should be somewhere around K equals approximately 2.95. Alright, and so the values of our unknown P here, alright, oops, sorry about that, but circling that, alright, and then my unknown, let's see if I can do that, there we go, and so my other unknown K, alright, here, alright, so here's K, here's P, alright, and here's the solution for problem 2 in that handout.